Good afternoon, everyone. In last lecture, we have seen this Dwayne and Hunt's rule. In that relation, I have told you that this kinetic energy is equal to E into V. That is, V is velocity. So sorry for that. By mistakenly, I have told you that. But this V is voltage. This kinetic energy is in electron volt. This is in electron volt. So this is the E is a charge on electron and V is the voltage. Okay, so like this way you can consider this. Okay, so here in this lecture we will see the Mosley's law, and this Mosley's law we will see the first statement of this Mosley's law, mathematical statement. Square root of the frequency is proportional to the atomic number. Okay, this is the statement of this Mosley's law. And here, by removing this sign, I am writing here constant. This is the constant. Okay, so here this A and B are the constants. What is A and B? Are the constants. And this constant which are dependent upon the spectral line. Which spectral line we have selected? This A and B constant dependent upon the spectral line. Which spectral line we have selected? Which means which spectral line? Either it is K alpha, either it is K beta. Depends on you which you are selecting spectral line. Okay, so this A and B depending upon this which spectral line you are selected. Okay, so this is the constant. Here suppose this scientist Mosley studied more than 35 elements, and the atomic number of these 35 elements have more atomic numbers, that is high atomic numbers. Okay, so Mosley studied 35 near about elements, and he had concluded and he had observed that the spectral line of all the elements are different. Okay, spectral line of all the elements are different because he had observed the spectral line of near about 35 elements, and he had concluded that the spectral line of that all 35 elements are different because the frequency of that spectral line is different. So we know that the frequency is different, that means its wavelength is also different. Okay, so this this is the spectral lines. Okay, this is the spectra, X-ray spectra, and in that X-ray spectra I have shown you that this is the spectral lines, that is K alpha and K beta. Okay, so here we will see this Mosley's law, and mathematical statement of this Mosley's law is square root of frequency of spectral line is directly proportional to the atomic number. Okay, so here I am writing the spectral line, the frequency of spectral line in the characteristic X-ray spectra. Okay, we have know that the spectra having two types, either it is characteristic, it is continuous. Okay, this is a characteristic X-ray spectra. So consider, suppose this is a spectral line, and frequency of that spectral line which is proportional to the atomic number. Okay, in the continuous X-ray spectra किंवा spectrum varies directly as the square of the atomic number Z. ओके, व्हॅरी आहे म्हणजेच काय, फ्रिक्वेन्सी कोणाशी व्हॅरी आहे, Z स्क्वेअर. सो square root of this frequency is directly proportional to Z minus B. Okay, this is the constant. By removing this, I am writing z minus b. These are the constants, and which is depending upon the which spectral line we have selected. Okay, so here we will solve this mathematical form of this expression, and here the value of in case of k alpha spectral line, in case of k alpha spectral line, the value of a is 3 by 4 rc. Okay, 3 by 4 rc, and value of b is 1. What is r? Is a Rydberg constant, and c is velocity of light. Okay, so value of this in case of k alpha spectral line a and b. By putting this value here, and we will calculate the value of nu is 3 by 4 rc 1 minus 1 by 4. Okay, rc z minus 1. Here this value I am consider here, and this 3 by 4 minus 1 by 4, this will give rc into bracket z minus 1 1 upon 1 square minus 1 upon 2 square. Okay, this. Okay, so here what is 1 and what is 2? Here here this 1 and 2 is the shells. Here electron transition take place from L shell to the K shell. In case of K alpha radiations, in case of K series, there is a transition is possible from L shell, M shell, N shell, various infinity shells to the K shell. Okay, for the this is the value of n1 and n2. Okay, here this the frequency, square root of frequency is rc into z minus 1 into bracket 1 upon n1 square minus 1 upon n2 square, because here transition of electron from L shell to K shell. Okay, so this, when this transition occurs, this we will call this K alpha radiations. Okay, so we will called K series. Okay, this is the value for frequency. This is the Mosley's law. Okay, here r is the Rydberg constant, c is the velocity of light, and n1 and n2 is the principal quantum number. This n1 is K shell, I have written here, and n2 is L shell. Okay, here the transition from L shell to the K shell is possible, and this is the K series. Okay, so this is about the Mosley's law. Okay, so here in next lecture we will study the fine structure of X-ray spectra, and after that agar electrons we will see. Okay, so here a half chapter is covered, only two points are remaining in this chapter. Okay, so in spectroscopy there is a interaction of the electromagnetic waves with matter is important. Interaction of electromagnetic wave means what? Here the interaction of X-rays with matter, and we will get the X-ray spectra. So the X-ray spectra having two types, that is characteristic X-ray spectra and continuous X-ray spectra. And this characteristic and continuous X-ray spectra we have discussed in detail in last lecture. And next after this chapter we will discuss about molecular spectroscopy and Raman spectroscopy. Okay, so thank you for today. One point that I have forgotten to explain you, this is the Mosley's plot. In that Mosley's plot, this Mosley has taken on this axis is a root nu, that is frequency, and in this axis that is atomic number. Okay, by plotting root nu against atomic number, he had found that when he plotted this graph and the graph of this k alpha and k beta spectral lines are found to be straight line. तो तुम्हाला दिसतोच आहे, स्ट्रेट लाईन असतो. पण जसं जसं तुम्ही ॲटॉमिक नंबर वाढत वाढत जाईल बघा, वाढत 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 जाईल तसं त्याची फ्रिक्वेन्सीसुद्धा काय होते, इन्क्रीज होते. काय होते, जसं जसं तुम्ही ॲटॉमिक नंबर वाढवत जाल तसं तसं त्या स्पेक्ट्रल लाईनची फ्रिक्वेन्सीसुद्धा काय होते, इन्क्रीज होते. तेच खूप महत्त्वाचं रिझन आहे की काय होतं, जसं इथं डायरेक्टली प्रोपोर्शनल रिलेशन आहे. म्हणजेच काय की जसं तुम्ही फ्रिक्वेन्सी वाढवत वाढवत जाल तसं तसं तो ॲटॉमिक नंबर आहे तो वाढायला पाहिजे. जर ॲटॉमिक नंबर त्या एलिमेंटचा वाढला तर त्याची फ्रिक्वेन्सी ऑब्वियसली काय असणार आहे, जास्त असणार आहे. आणि इट इज अ व्हेरी युजफुल फॉर द प्रोडक्शन ऑफ एक्स-रेज. Okay, we require for the better production of X-rays, we require higher frequency radiations. Okay, so here Mosley's importantly say that this frequency is dependent upon the atomic number. When this atomic number get increased, the frequency obviously increases, and we got the higher frequency radiations. Okay, so we get the high energy x-rays, and which is this x-rays having high penetration power. Okay, so this is the most main point discovered by Mosley, and this law is called as Mosley's law. Okay, so thank you.